This is actually we have done the climbing stairs or top-down approach. This code we executed and it ran fine. Now in this video we'll code the bottom up approach of this climbing stairs. If you haven't watched my previous video where I explained this bottom up approach in theory, please watch that video before coming to this. This is just the code session of that. I'll paste the link in the description if you forgot. So in the bottom approach, like I explained the whole code on the paper, right? So you should watch that video first. I'll just do that particular coding here. Hmm. So we'll maintain an array. So as per our base condition, what was our base condition? If n is less than equals to 2, then we need to return n simply. Otherwise, we'll create an array. That is the memorization approach. Size would be obviously the n plus 1. Just to avoid the array index out of bound. We'll initialize with the base conditions, like whatever is the base condition. These are the base condition. Now like till dp of 2 we have initialized, right? So we'll run a loop from I equals to 3 will I less than equals to n. So we'll fill the dp. What are the dp of I will be the sum of the previous two. Simple. N minus 1. Sorry, I minus 1. dp of I minus 2. So like we at the end of this loop we'll having like on the end we are at the end position and the array is filled, right? So we just simply need to return a dp of I. That's what we have done, right? Just test it. So for the normal cases it ran. Let's submit it to see the other cases. So it's like beats 100% of the users, right? Runtime is very less because like we have introduced a dp. So yeah, this by this code, like we have covered up this climbing stairs. First recursive explanation, then recursive code, and then we have seen that the recursive code was exceeded because of the time. We were seeing some overlapping problem, and we are calling that function again and again. The solution was that to use the memorization. So first I explain you on the paper like how to fit the memorization into recursive, so to avoid the again calculating the same thing, right? So that thing we have understood. Then I explained you the top down, like in the memorization there are two approaches. Top down approaches I explained you on the paper, then we created a code of that, and after that I explained the bottom up approach on the paper, then this is the code of that. So by this complete series, like we have completed a concept of recursion and how to introduce the concept of memorization when there is an overlapping problem, and when there is some overlaps into recursion that can be solved using dynamic programming. Dynamic programming is nothing but introduction of the memorization to avoid the unnecessary recursive call or repeatedly recursive calls. And then the two approaches of using memorization, top down and bottom up. So this is completed now. We'll in the next lecture we can take some more different questions to understand the concept better. Thanks.